Hello, guys and girls. Welcome to our very first grade 10 mathematics tutorial. In this video, we will be revising the June 2022 common test. We will be doing algebra, factorizing, simplifying, solving for x, solve equations simultaneously for x and y. We also have number patterns and functions or graphs for today. Grade 10s, please note that we'll be uploading a new grade 10 mathematics tutorial every Friday, or at least 2 or 3 times a month. So you better make sure you subscribe to the channel right now so that you don't miss any of our tutorials. Okay, go right ahead now and subscribe on the big red button. I will wait. Go on, I'm waiting for you to subscribe. Okay, now that's done. That's great. Also, I would like to let you know that private tutoring is available here on Student Tools in two categories. Either you sign up for a group session or you sign up for a one-to-one tutoring session. So if you're interested in that, make sure you check out the link in the description. With that said, let's dive into our revision. All right, question 1, we have 1.1. And 1.1 says we should simplify the following expression fully. All right, so we have this expression 1 over 3x squared y multiplied by a 6x minus 9 over 2 x to the power minus x minus 2 y squared. All right, so we're given this and we're supposed to simplify fully. So we will first multiply 1 over 3x squared y with the 6x, this one. So first we will multiply the coefficients, which is 1 over 3 and the 6. So 1 multiplied with a 6, that is equal to a 6 over 3. 1 over 3 multiplied by 6, that's equal to a 6 over 3, and 6 over 3 is 2. And that means we have a 2 multiplied with an x squared multiplied by an x. Because we are multiplying, we will add the indices. So here we have x to the power 1. So we will have x to the power 2 plus 1. So that's a 3. And then we bring this y. Next, we have 1 over 3x squared y multiplied by a 9 over 2x to the power minus 2 y squared. So again here we will first multiply the coefficients. We have a 1 over 3 multiplied by a minus 9 over 2, because here we have a minus, so this will be in minus 9 over 2. So again here we will have this equal to a 1 multiplied by a minus 9 or a negative 9, that's equal to a negative 9 over 3 multiplied by a 2, that's a 6. So when we divide with a 3 here, we will get a 2. Also when we divide with a 3 here, we will get a minus 3. So this is the same as negative 3 over 2. So back here we will have a minus 3 over 2. And then we come to the x squared multiplied by this x to the minus 2. Because we add the indices, this will be 2 plus minus 2, which is the same as 2 minus 2. So that's a 0. So anything to the power 0 is 1. So x to the power 0 will be 1. 1 multiplied with a 1 here, 3 over 2 multiplied by a 1. And then we have y multiplied by y squared. So y to the power 1 multiplied with the y squared, we add the indices, so this will be y to the power 1 plus 2. So that's a 3. So now that we have this, we will have 2x to the power 3 y minus 3 over 2 multiplied by a 1, that's a still 3 over 2 y to the power 3. And that is just how we simplify 1.1. Okay, next question. All right, so now we are on 1.2. 1.2 says factorize the following expression fully. All right, so we have this expression and we are supposed to factorize it. So how are we going to factorize this one? This expression is the same as a difference of two squares. So we are going to tackle it as a difference of two squares. So how do we usually factorize a difference of two squares? Let us say maybe we had an x squared minus a 9 and we're supposed to factorize it. It's a difference of two squares. So in this case, this is what we usually do. We take our two brackets, we'll put an x here, also an x here. Why? Because it's the square root of x squared. And then here we have the square root of 9, which is a 3, and also here a 3. Here we'll have a plus, and here we'll have a minus. It is just how we factorize a difference of two squares. A square root of this and a square root of that plus minus over there. So we'll do the same thing here. We have a plus 1 squared. So what is the square root of a plus 1 squared? Let us first write our two brackets. We have a plus 1 squared. What's the square root of a plus 1 squared? That is a plus 1. Let us put it in brackets. And again here we'll put the square root of a plus 1 squared, which is a plus 1. And then here we'll have to find the square root of 4b squared. And again, that's a 2b, also a 2b over there. Here we will have a plus, and here we will have a minus, just like here and there. All right, now that we have this, we have a plus 1 plus 2b, close bracket, a plus 1 minus 2b. It is just how we factorize this expression. Okay, next we have 1.3. 1.3, solve for x. We are given 1.3.1. We have this expression whereby we are supposed to solve for x. We have x plus m multiplied by an x minus n equal to a 0. And here we are supposed to solve for x. So how are we going to solve for x in this case? All right, first step is we will take whatever is in the first bracket and have it equal to 0. So x plus m equal to 0. Or take whatever is in the second bracket, have it equal to 0 as well. So that is x minus n equal to 0. So with each of these, we will have to make x the subject. So to make x the subject, we will have to take m from the left-hand side to the right-hand side. So we'll do that by subtracting m over here and also subtracting m over here. So this will be 0, such that x will be equal to a 0 minus m, that is a negative m. So again, this side, to make x the subject, which is what we are supposed to do, we will have to take n from the left-hand side to the right-hand side. So we'll do that by adding m, because we have a minus n. So we will add n here and also add n over there. So minus n plus n, that's a 0. So x will be equal to a 0 plus n, that is a positive n. So x is equal to a minus m, or x is equal to a positive n. And that is just how we solve for x in this case. Next, we have 1.3.2. 1.3.2, we're still solving for x, and we have this expression, 4 to the power x minus 4 to the power 0 minus 255 equal to a 0. All right, so we're given this and we're supposed to solve for x. So first step is we have 4 to the power x. There's nothing we can do about that. And that is minus 4 to the power 0. Anything to the power 0 is equal to a 1. Yes. So we have a 1 over here, and we bring the minus 255 over here. All this is equal to a 0. So 4 to the power x minus 1 or negative 1 minus 255, that is a minus 256, or a negative 256 equal to a 0. So we will have to take the minus 256 from the left hand side to the right hand side. So we will do that by adding 256 on this side, also on this side. So this will be a 0, such that 4 to the power x will be equal to a positive 256. Now let us make everything to the base 2. So to make this to the base 2, this will be equal to 2 to the power 2 to the power x. So 2 to the power 2, that's a 4. So it's this 4, which is this base, and that base is to the power x. So all this is equal to 256. 256 to the base 2, that is a 2 to the power 8. All right, now we have this. So 2 to the power 2 to the power x. When we have something like this, we can multiply the indices. So we will have 2 to the power 2x equal to 2 to the power 8. So now we have the same basis. So we can now say 2x, which is from the index, equal to the under index, which is 8. So to solve for x, we will have to divide by 2 both sides. This will cancel this, and 2 here once, 2 here 4 times. So x is equal to a 4. And that is just how we solve for x in this case. Next question. 1.4, simplify the following. All right, so here we have an exponential expression. So we have a 2 to the power x plus 2 multiplied by a 7 over 2 to the power x plus 4 minus 6 multiplied by a 2 to the power x plus 1. All right, let us simplify this. First, we need to expand this. So to expand this, we will have a 2 to the power x multiplied by a 2 to the power 2, which is this one. And then we bring the 7 multiplied by a 7 over 2 to the power x multiplied by a 2 to the power 4 minus a 6 multiplied by a 2 to the power x multiplied by a 2 to the power 1. So we don't really have to write the 1. We can just write the 2. All right. So what can we do next? At the top, there's nothing we can do. Let's just write 2 to the power x multiplied by 2 to the power 2 multiplied by 7, and this is over that. In this case, when we have something like this, we can look for a common factor. So here we have a common factor of 2 to the power x because it's here and here. Let us take also 2 to the power 2. Yeah, let us take 2 to the power 2. So we have 2 to the power x multiplied by 2 to the power 2. We will factor it out. So to get this, 2 to the power x multiplied by 2 to the power 4, we will have here a 2 to the power 2, because when you multiply this and this, it will give you 2 to the power 4, and then we will then have this 2 to the power x over here. So this will be minus this 6, which will have to be multiplied with a 2 to the power minus 1, because here 2 multiplied by minus 1, it is 2, this 2. So then we close this bracket, and then when we have something like this, we can now cancel this, and this will cancel this, such that we will have 7 over 2 to the power 2, that's a 4, minus 6 multiplied by 2 to the power minus 1, that's a half. So 6 multiplied by a half. Right, now we have 7 over 4 minus 6 multiplied by a half, that's a 3. And 7 over 4 minus 3, that is a 1, which is a 7. And that is just how we simplify whatever was in this question. So our final answer is a 7. Okay, up next we have question 2. Question 2, we are doing sequences or number patterns, guys and girls. So we have 2.1, which says consider the general term Tn equal to 1 over minus 2n plus 5. And then we have 2.1.1, which says write down the first two terms of the sequence. All right, so we have this general term, and we are supposed to find the first and the second term of this general term. So let us first find the first term, which is T1 will be equal to a 1 over minus 2n. 2n, we are replacing it with a 1. So here we'll have a 1 plus a 5. So this will be equal to a 1 over minus 2 multiplied by a 1, that is a negative 2, plus a 5 equal to a 1 over minus 2 plus a 5, that is a positive 3. So the answer to the first term is going to be a 1 over 3. So what's the second term? Now let us find the second term. So we will have T2 equal to a 1 over minus 2 multiplied by a 2. We are replacing n with a 2. Close bracket, plus a 5. This will be equal to a 1 over negative 2 multiplied by a 2, that is a negative 4, plus a 5. So this will be equal to a 1 over negative 4 plus 5, that's a positive 1. So this is equal to a 1. That means the second term of this general term is a 1. And the first two terms are 1 over 3 and 1. And it is just how we do 2.1.1. Up next, we have 2.1.2. All right, 2.1.2 says determine which term in the sequence has the value of minus 1 over 395. So with this general term that we have, let us use it to find which term of the sequence has a value of minus 1 over 395. So let us take the equation of the sequence, which is 1 over minus 2n plus 5, and have it equal to a 1 over 395 minus a negative 1 over 395. So now let us make n the subject to find the value of the sequence, which is equal to that. So to make n the subject, we will have to multiply both sides with a minus 2n plus 5, and also multiply with a 395. We want to get rid of the fractions, or the denominators, I mean. So we do that on the left hand side, we also have to do it on the right hand side as well. So we multiply with a 395 and a minus 2n plus 5. So this will cancel this, and this will cancel this, such that we'll have 395 multiplied by a 1. So that's going to be 395 equal to a minus 1 multiplied by a minus 2n plus 5. So we will have minus 1 multiplied by minus 2n. Negative multiplied by a negative, that means we have a positive. So here we will have positive 2n. And then negative 1 multiplied by a 5. It's going to be a minus 5. So now we have something like this. We have to make n the subject. So we will do that by taking the 5 from the right hand side to the left hand side. We will do that by adding 5, because we have a minus over here. So we will also add the 5 over here. So 395 plus 5, this is going to be a 400 equal to a 2n. This will be equal to a 0. So we'll have to divide by 2 both sides to make n the subject. So this will be 1 and this will be 1. Such that here 2 divided by 2 is 1, and 4 divided by 2, that's going to be a 2, and they cancel these zeros, which means we have 200, and n is equal to a 200, or n, well, let's write it like this, n is equal to a 200. So that means the value of the sequence, which is equal to a minus 1 over 395, is when n is equal to 200. And that is just how we determine that. All right, let's move on to 2.2 says, consider the following sequence, 5 up to a c. The general term for the sequence is Tn equal to 2n plus 3 over n squared. Determine the values of a, b, and c. All right, so we have this sequence, this one, and we have this general term, Tn equal to 2n plus 3 over n squared. So our task is to find the value of a, b, and c. So how are we going to do that? We'll use the general term, since this is term 1, term 2, term 3, term 4, term 5, term number 6. So we will first have to find term number 3 using the general term. So to do that, we'll have t number 3 equal to 2 multiplied by n, and n we are replacing it with a 3, plus a 3 over 3 squared, because we are replacing it with the 3. So this is equal to 2 multiplied by 3, that's a 6, plus a 3 over 3 squared, that's a 9, equal to 6 plus 3, that's a 9 over 9. This is equal to a 1. So that means a is equal to a 1. Now let us find the value of b. The value of b is term number 4. So to find term number 4, we have t4 equal to 2 multiplied by a 4 plus 3. We're putting 4 here because we're replacing n with a 4. So this is over 4 squared. Again, here we are replacing n with a 4 because n is squared, we have 4 squared. So this is equal to 2 multiplied by a 4, that is an 8, plus a 3 over 4 squared, that is a 16, equal to a plus 3, that's an 11 over 16. So if term number 4 is equal to 11 over 16, that means b is equal to an 11 over 16. So now we are supposed to find the value of c, which is term number 6. Term number 6 is equal to 2 multiplied by a 6. Here we are replacing n with a 6 plus a 3 over n squared. We're replacing n with a 6, so it's 6 squared. This is equal to 2 multiplied by a 6, that is a 12, plus a 3 over 6 squared, that is 36, equal to 12 plus 3, that is 15 over 36. So now we have 15 over 36. We can still simplify this by dividing by a 3 because it's a common factor. So when we divide 36 with a 3, we're getting a 12. And when we divide 15 with a 3, we get a 5. So that means we have a 5 over 12 here. Term number 6 is equal to 5 over 12. And that means also c is equal to a 5 over 12. And that's just how we get the value of a, b, and c, ladies and gentlemen. Now we're done with this question. On to the next one. 2.3. The first 4 patterns in a sequence are shown below. Each pattern is made from dots and 1 centimeter lines. The area of each small square is 1 centimeter squared. So we have these patterns, and below we have 2.3.1, which says use the table and the pattern above to determine the values of A, B, C, and D. Right, so we have this table showing pattern, area, number of dots, number of 1 centimeter lines. So we are supposed to determine the value of A, B, C, and D. So how are we going to do that? For A, we have to show the area in centimeters squared of the pattern number 5, which means it's the pattern after this one, pattern number 4. And B, we are supposed to determine the number of dots that are on pattern number 2. this one. So we are supposed to determine the number of dots which are on that pattern. But I think this is the easiest. So let us start with B. So number of dots that are on pattern number 2, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 number of dots that are on pattern number 2. So let us write it down here on the table. We have 12 dots here. So we are left with A, C, and D, which are specifically for pattern number 5, which we do not have on the diagram. So that means we will have to use another method to get those values. So let us start with the value of A, which requires the area in centimeters squared. So we cannot measure this because we also do not even have the diagram. We will use this sequence: 2, 6, 12, and 20 to find the area in centimeters squared of pattern number 5. Alright, let's do that. So we have this sequence: 2, 6, 12, 20, and then here we have A. I'll just leave it empty. So to find the value of A, we must configure this sequence. So what kind of a sequence is it? I will check by finding the first differences. 6 minus 2, that is a 4. 12 minus 6, that is a 6. 20 minus 12, that is an 8. Already we are seeing a trend here. The common difference between the first differences is 2. That means if we were to find the difference between this unknown, which is A, and 20, we would get a 10. Because the difference between 10 and 8 is also 2. So that means if we want to find A, we would have to add 20 and 10. So if we add 20 and 10, we're getting a 30. So that means the value of A is equal to a 30. So now let us write that on our table. A is equal to 30. Now we are done with A. Let us find the value of C. And here we have a sequence of the number of dots. We will use this sequence of the number of dots from pattern number 1 up to pattern number 4 to find the value of C. So let us do that. We have 6, 12, 20, 30, and then we have C. Again, we will first check the first differences so that we can understand what kind of a sequence it is. So first difference is we have 12 minus 6 here, so that is a 6. And then we have 20 minus 12, that is an 8. We have 30 minus 20, that is a 10. So again here, we getting a trend. This is a quadratic, so that means here we're getting a common difference, which is 2 again. So if we were to check the difference between 30 and C, so that will be here and here. That will be a 12 because the common difference is 2. So then how do we get C? We would have to add 30 and the 12. So 30 plus 12, that is a 42. So the value of C is equal to 42. So C is equal to a 42. And then last we have D. D, how do we get D? We will use this sequence of the number of 1 centimeter lines from pattern number 1 up to pattern number 4. Let's do that. So for the sequence of the number of 1 centimeter lines, we have 7, 17, 31, 49, and D. So now we will try to find the value of D using this sequence. Let us first check the first differences. We have 17 minus 7, that is a 10. And then we have 31 minus 17, that is a 14. Last we have 49 minus 31, so that is a 18. Again, here we are seeing a trend. So obviously here we have a common difference of 4. So that means if we were to find the common difference between D and 49, we would get a 22. Why? Because here we have a common difference of 4. So the difference between 22 and 18 is a 4. So again, to find D, we would have to add 49 and 22. So what is 49 plus 22? That is a 71. So D is equal to a 71. Okay, let's remove this so that we can write the 71, or the value of D. Value of D is 71. And that is just how we complete this table using these sequences for each category. So now let us move on to the next question. 2.3.2, the area of the pattern n can be written as the nth term equal to n multiplied by n plus 1 centimeter squared. Find the area of pattern number 50. So we have the general term of the pattern as equal to n multiplied by n plus 1. So this general term gives the area of the pattern in centimeter squared. And then we have to find the area of pattern number 50. So pattern number 50, which is term number 50, is equal to 50. Because we have n there, we will substitute n with the 50. And then multiply this by n plus 1. So that means we have 50 plus 1. Close a bracket. Term number 50 will be equal to a 50 multiplied by a 50 plus 1. That is a 51. And then we close a bracket. Term number 50 is equal to 2,550. So that means the area of pattern number 50 is equal to 2,550 centimeter squared. And that is just how we find the area of pattern 50. All right, now let us move on to the next question. Question 3, we have 3.1. The graphs of f of x equal to ax squared plus q and g of x equal to mx plus c are sketched below. The graph of f intersects the x-axis at -4, 0 and b, and the y-axis at 0, 4, which is also the turning point of f. One of the points of intersection of f and g is A. All right, so we have f here. This one, this is f. And we have G over there, the straight line. So we are told that the graph f intersects the x-axis at -4, 0. So here, that's the x-intercept, and b, we're not told the values of b. So also the y-intercept is at 0, 4. which is also the turning point of the graph f. So we are also told that graph f and g, they meet or they intersect at point A, this one. So we have some questions below the graphs. Use the graphs and the information given above to determine the equation of G. So we are supposed to determine the equation of the straight line G. So we are given that G is equal to mx plus c. So G is equal to mx plus c. That is the same as y equal to mx plus c. So to find the equation of G, we know that we have to find the value of m, we have to find the value of c, and m is the gradient. So to find the gradient, we need 2 points or coordinates that are on G. So what are those points that we can use? We have this coordinate and also this one. So that means we have 0, 2. This one, it's the y-intercept. And then we have negative 4, 0, which is the x-intercept of f and g. So to find the gradient, we have this formula, y2 minus y1 over x2 minus x1. So we will call this our x1, y1, and this will be x2, y2. So now let us find the gradient using these values. So the gradient is equal to y2, we have 0, minus y1, that is a 2, over x2, we have negative 4, and x1 is equal to a 0, so we will subtract 0. The gradient will be equal to 0 minus 2, that is a negative 2, over negative 4 minus 0, that will be a negative 4. So that means our gradient is equal to a half, because negative 2 over negative 4 is equal to a half. Okay, now we have the gradient. What we are left with is the value of c. We do not know the value of c, so let us now try to find the value of c. So again, we have g of x is equal to mx plus c. So now we know the gradient. That means g of x is equal to 1 over 2x plus c. And now that we're here, because we want to find the value of c, we will use one of the coordinates, this one, to find the value of c. So we will do that by substituting y with a 0. So that means here we have g of x as y. So we will substitute g of x with a 0. And then substitute x with a negative 4. So now let us do that. So for g of x, we have 0 equal to 1 over 2. X we're substituting with a negative 4. So this will be multiplied with a negative 4 plus c. And then 0 will be equal to negative 4 multiplied by a half, that is a negative 2 plus the c. So to make c the subject, we would have to take negative 2 from the right hand side to the left hand side by adding 2 and also add 2 here. So this will be 0, such that c will be equal to a positive 2. So we can write it like this. C will be equal to a positive 2. So now we have the value of c. So that means now we can determine the equation of g. So g of x will be equal to, the gradient is equal to a 1 over 2x, and then c is equal to a positive 2. So this is how we get the equation of g. Okay, now let us move on to the next question. 3.1.2, use the graph and the information given above to determine the values of A and Q. So we have to determine the values of A and Q. And where do we find A and Q? We find A and Q here on graph F. So graph F, we have f of x equal to ax squared plus q. So graph F is a parabola. We have a function f of x equal to ax squared plus q. We have to determine the value of a and the value of q. So what are we given on this parabola? We are given the x-axis, which is -4, 0 here. The x-axis. So let us write it down so that we can see what kind of information we can use to get the value of a and q. So we have the x-intercept, which is -4, 0. And then we also have the turning point here, 0, 4. So we have a turning point, which is 0, 4. Alright, we can find the function of a parabola using two methods. One method is when we are given the two x-intercepts, and the other method is when we are given the turning point. But here we are given one x-intercept. So that means the only method we can use is the one where we are given the turning point. So we will use the formula which requires the turning point. So what's that formula? So the formula that we use when we have a turning point is y equal to a multiplied by x minus p squared plus q. And on this formula, the p and the q is given by the turning point. So for p, it will be given by the value of x of the turning point, and then q will be given by the y value of the turning point. So in this case, we have the turning point as 0, 4. So let us try and plug it into our formula so that we can see where that gets us to. So we have y equal to a multiplied by x minus p. So that is given by the x value of the turning point. Our turning point is 0, 4. The x value of the turning point here is 0. So we'll plug that 0 in and close a bracket and square plus q. So the q is given by the y value of the turning point. Our y value here is 4. So that means we are adding a 4. And then y will be equal to a multiplied by x minus 0. So that is still x. So that means x here is going to be squared. So let's remove the brackets. So that means we'll have x squared plus 4. So as you can see, we already have the value of q. So q is equal to a4. So we can write it down already. Q is equal to a4. So we already got the value of q. What we are left with is the value of a. So how do we find the value of a? We will use a coordinate that is on graph F. So on graph F, we also have this x-intercept. Let us use the x-intercept to find the value of a. So we have this expression now. So for y, we will substitute with a 0 because we are using this coordinate. And then for x, we will substitute with a -4. So now let us do that. So here for y, we have 0 equal to a. And then for x, we will put in the negative 4 and square it. So we have plus 4 here, and then 0 equal to a multiplied by negative 4 squared. So negative 4 squared, that is a 16. So that means we have 16a here plus 4. So we want to make a the subject, we will have to take positive 4 from the right hand side to the left hand side. So we'll do that by subtracting 4 here and also subtract 4 on the left hand side. So this will be a 16a equal to a negative 4. So this will be a 0. So here we have a negative 4 because 0 minus 4 is equal to a negative 4. So to make a the subject, we will have to divide here by 16, both sides. So this will cancel this, and negative 4 over 16 is negative 1 over 4. So this is equal to a. So a is equal to a negative 1 over 4. And that is just how we find the value of a. A is equal to a negative 1 over 4. And q equal to a positive 4. So that is just how we find those values. Now let us proceed to 3.1.3. 3.1.3, use the graph and the information given above to determine the coordinates of B. Okay, so B is the other x-intercept of graph F, and that is what we are trying to find. We already have one x-intercept that is negative 4, 0. So we want to find the other one, which is at B. So let us try and find the x-intercept of F. Let us write the equation of our graph F. So graph F, we have f of x equal to a negative 1 over 4 x squared plus 4. So this is the equation of graph F, and we want to find B. B is the x-intercept. So when we want to find the x-intercept of a graph, we have to make y equal to 0. So because we have f of x here, so that means we will make f of x equal to a 0, and then we solve. So now let us do that so that we can find the other x-intercept of f. So here that means 0 will be equal to a negative 1 over 4 x squared plus 4. So we made y equal to a 0, or f of x equal to a 0, because f of x and y is the same thing. So that is why we have this. Now we have to solve for x. So to solve for x here, we'll first take negative 1 over 4x squared from the right hand side to the left hand side. So we'll do that by adding 1 over 4x squared. So this side will also add 1 over 4x squared. Why? Because it's negative on the right hand side. Such that here we will have 1 over 4x squared equal to a positive 4. And then when we have this, we can get rid of the denominator. So we'll get rid of the denominator by multiplying by a 4, and also multiply with a 4 on the right hand side as well. So this 4 will cancel this 4, such that here we will be left with an x squared equal to a 4 multiplied by a 4, that is a 16. So here we have x squared. To get the value of x, that means we have to use a square root. So we'll use a square root both sides. So here we will have x equal to the square root of 16. X will be equal to the square root of 16. So the square root of 16 is plus or minus 4. So that means we have one x-intercept at x equal to a positive 4 and one x-intercept at x equal to a negative 4. So we already have x equal to a negative 4. So what is the other value of the x-intercept? That is the positive one, because it's on the right hand side of the y-axis. So we have a positive 4 here. So b will be equal to a positive 4 comma 0. So those are the coordinates of b. All right, now we are done with 3.1.3. Let us move on to 3.1.4. And 3.1.4 says, use the graph and the information given above to determine the domain and the range of f. Okay, let us first define these terms, domain and range. So what is a domain? A domain refers to the input values. And then the range refers to, we didn't put 2 here, to the output values. So what can we say about the domain and the range of graph f, the parabola? Or what can we say about the input and the output values of f? From this diagram, the domain, because when we are talking about the domain, we are talking about the input values. That means we are talking about the x values of the graph f. So from this, what we can say is that x is an element of real numbers. And then the range, which is the output values. So the output values or the y values. So what can we say about that? What we know is that this graph can go this direction as further as it wants and this direction as further as it wants, but it will end here. It will not go that direction, but it will turn and go back to the other direction. So that means our y values are less than these 4. So they are less or equal to this 4, because we have the turning point here. So y would be less or equal to a positive 4. Okay, that is how we determine the domain and the range of f. Now let us move on to the next question. 3.1.5. Use the graphs and the information given above to determine the equation of k of x if k is the graph of f reflected about the x-axis. Okay, so we have the graph f here. So we are told that we have to find the graph k here through what? Reflecting this graph f about the x-axis. So what do we know about reflecting graphs? Let us say we are reflecting about the x-axis and the y-axis. So what do we know about that? What we know is when we are reflecting a graph about the x-axis, what do? We negate y. And when we reflect a graph about the y-axis, what do? We negate x. And then here we are told that we are reflecting this graph f about the x-axis to get this one. So now let us do that so that we can determine this graph K. So we have graph f, this one, I want us to write it as y equal to this. So we will have graph f as y equal to a negative 1 over 4 x squared plus 4. And we are reflecting about the x-axis. So that means we will negate y. So this is what we will negate. We will negate this y. And then we'll make y the subject, not negative y. Because now we have negative y as the subject. So that means we will have to take this y from the left hand side to the right hand side. So we will do that by adding y here and also add y on the right hand side, such that we will have 0 equal to a negative 1 over 4x squared plus 4 plus y. And now we want to take this from the right hand side to the left hand side. So how are we going to do that? We will add this 1 over 4x squared and subtract this 4. So this is what we will do also on the left hand side. So we will add 1 over 4x squared and subtract this 4, such that this will cancel this to a 0. So here we will have this positive 1 over 4x squared, and here we have minus 4. All this is equal to this y. So we'll put the y here. And now we can write this equation as y equal to a 1 over 4x squared minus 4. Okay, so this is the reflected graph, but we want to describe it as K. So we will say K of x is equal to a positive 1 over 4x squared minus 4. And that is just how we determine the graph of K, which is the reflection of this f. Now let us proceed to 3.1.6. 3.1.6, use the graph and the information given above to determine one value of x for which f of x is equal to a 0. Okay, so here we are supposed to determine one value of x where f of x is equal to a 0. So actually this is the same as finding the values of the x-intercept, because this is the same as where y is equal to a 0. So when we were doing 3.1.3, we found that here we have negative 4, 0. And here we have positive 4, 0. So here we have y is equal to 0, and here we have y equal to 0. So you can choose any of these x values that you want to use, but the question said you must determine one value of x for which f of x is equal to a 0. So it's either you use negative 4 or you use a positive 4. It's up to you. But those are the values which you should determine, because they are the values of x where f of x is equal to a 0. Okay, now we move on to 3.1.7. 3.1.7, use the graph and the information given above to determine the values of x for which f of x is greater than g of x, given that a is 2, 3. Right, so they say here we are given that a is 2, 3, and we have to determine where f of x is greater than g of x. All right, so we have this graph f and we have this straight line g. So we want to determine where f is greater than g of x. So from here we can see that g is greater than the straight line. So here it's still greater until here at a, which is 2 comma 3. So that means here we have an x value of 2, and here we have a negative 4. So to determine this area where f of x is greater than g, the straight line, we would have to say this area is when x is greater than this negative 4. So it's when it's greater than this negative 4, but it's less than this positive 2. So we will say less than positive 2. And that is just how we determine the values of x, where f of x is greater than g of x. Okay, now we are done with 3.1. Let us move on to 3.2. 3.2, the function h of x is equal to k to the power x plus q, is described with the following properties. K is greater than 0 and k is not equal to 1. So let us write it down. We have k greater than a0 and k is not equal to a1. So we also have h of 0 is equal to a negative 7. So what does this tell us? This means that this is the y-intercept. Why? Because x is equal to a 0. And then we have h of 3 equal to a 0. So what is this now? This is the x-intercept of h. And last but not least, we have a horizontal asymptote, which is at y equal to a negative 8. So we are given an instruction to sketch this graph using the information provided. We draw a neat sketch of the graph h of x equal to a k to the power x plus q. So we will use this information to draw this graph. I already have a grid here and our pair of axes to do that. So let us sketch this graph. We will start with the horizontal asymptote. So we have one asymptote because this is an exponential graph. So we start with our asymptote. Our asymptote is at y equal to a negative 8. So here, let us correct this. So let us correct this. We have negatives here. So at y equal to a negative 8, this one, we have our horizontal asymptote. So let us draw our asymptote. We have our asymptote here. You will use a ruler because you want your graph to be neat. So what else do we have? We have the x-intercept. We have the x-intercept at 3, 0. So that means our x-intercept is over here. Why do we say our x-intercept is at 3? It's because here we have the x value and here this is the y value. When you look at this, here we have the x. So that means our x was substituted with the 3. So that's why the x-intercept is 3, 0. And then what else is given to us? We're given that h of 0 is equal to a negative 7. So that means our y-intercept is at 0, comma, negative 7. So the y-intercept is over here. So that means our graph will be curving like this, but it will be approaching this asymptote, but it will not cross it. So that means here we will sketch this graph like this to be approaching the asymptote but not crossing it. So this is how our graph will look. You will have to draw a net graph. You will have to sketch a net graph. So we will label this as h. So we will label this as h. And here we write 3, 0. So that's the x-intercept, and here we have the y-intercept, which is 0, negative 7. And here we label our asymptote, which is y equal to a negative 8. Okay guys, that is just how we sketch this graph. And remember to label your graph and your coordinates, your x and the y-intercept. Okay, now we are done with question 3. Up next is question 4. Question 4, we are given f of x equal to a 12 over x plus 3. And that is a hyperbola. So we have 4.1, which says write down the equations of the asymptotes. So already we know that we have asymptotes, so we are sure that we are dealing with a hyperbola. So we have f of x equal to a 12 over x plus a 3. So when we are dealing with a hyperbola, we know that a formula for the hyperbola is y equal to a over x minus p plus q. So from this formula, we know that we have p and q. So p is equal to the vertical asymptote, and q is equal to the horizontal asymptote. So that means here we are getting an x equal to something, and here we are getting a y equal to something. And here we are given f. We could say f is the same as y equal to a 12 over x plus 3. And we want the two asymptotes of this graph. So with the way this graph is arranged, we can say that 3 is q, and q is equal to the horizontal asymptote. So here y will be equal to a 3 because it's taken from the value of q, which is 3 here. And what about the vertical asymptote? So the vertical asymptote is taken from the value of p. And p here, we don't have p. So that means p is equal to a 0, meaning that x is also equal to a 0. So those are our two asymptotes. The vertical asymptote is equal to x equal to a 0, and the horizontal asymptote is y equal to a 3. And that is just how we find those two asymptotes of this graph f. Now let us move on to 4.2. 4.2, determine the equation of G, the axis of symmetry of F, with a positive gradient. Okay, so here we want to determine the equation of G. And G, we are told that it's the axis of symmetry of F. So what do we know about axis of symmetry? The axis of symmetry passes through the asymptotes. So in this case, G will pass through the asymptotes of F. So what are the asymptotes of F? We have the horizontal and the vertical asymptote. So what are those two asymptotes? Okay, so for the horizontal, we have y equal to a3. And for the vertical one, we have x equal to a0. So when we say this G will pass through the asymptotes, we mean that it will pass through this coordinate 0, 3. And the other information we are given here is that the axis of symmetry, which is G, has a positive gradient. So when it has a positive gradient, it means we will use this formula. We will use y is equal to x plus c. If we were told that this axis of symmetry has a negative gradient, we were going to use y is equal to a negative x plus c. But then it's positive, so we're not going to use that. So now let us find this equation of the axis of symmetry, which is G. So we will use this coordinate to find that. For the value of x, we will substitute the 0, and for the value of y, we will substitute the 3 to find this c. So let us do that now. For y, we will substitute 3, which means that is equal to a 0 plus c. And that makes c equal to a3. So that means that equation is y equal to x plus 3. So now we want to describe it as G. So G of x will be equal to x plus 3. And that is just how we determine the equation of G. All right, now let us move on to the next question. 4.3. Sketch the graph of f and g on the same system of axes, indicating all intercepts with the axis and asymptotes. Okay, so here we are required to sketch this graph, and we should indicate intercepts with the axis and the asymptotes. So we already know the asymptotes of graph f. So we have the asymptotes as x is equal to a0 and y equal to a positive 3. So now let us gauge our asymptotes. I've already drawn the system of axes. We have our x and y axis. So now we have y equal to a 3, which is our horizontal asymptote. So let us sketch that. Y equal to a 3. So it will be here. And then we will label this as y equal to a 3. So what about our vertical asymptote? Our vertical asymptote is x equal to a 0. So that asymptote will be the y-axis. So we do not necessarily have to draw it because it will not be visible. So we have that y-axis as our asymptote. So what is left now? We are left with the x-intercepts because we know the graph doesn't intersect with the y-axis because we have the asymptote. So now let us find the x-intercepts. Okay, because we want to find the x-intercept, we know that when we want to find the x-intercept, we have to make y equal to a0. So that means f of x will be equal to a0 here. So 0 will be equal to a 12 over x plus 3. And then we solve. So to solve this, we will have to multiply everything with an x. So we'll multiply with an x here, an x here, and also an x here. So this x will cancel this x, such that this will be equal to a 0, because x multiplied by a 0 is 0. So here we have 12, because it's 12 multiplied with a 1, and then plus 3x. So to make x the subject, we have to take 12 from the right hand side to the left hand side. So we'll do that by subtracting 12 and also subtract 12 here. So this will be a 0, such that this will be equal to a negative 12 equal to a 3x. So to make x the subject, we would have to divide by 3 both sides. So this will cancel this, and 3 divided by 3, that will be 1, and negative 12 divided by 3, that's a negative 4. So that means we have a negative 4 here. Of course, x is equal to a negative 4. So our x-intercept is at negative 4, 0. So that's our x-intercept. So our x-intercept will be here. And what we should know, because a here is greater than 0, so that means our graph will be over here and over here. And we have our point of intersection of the asymptotes here. So now let us sketch our graph. So we will sketch it like this. Here we have the intersection, and the asymptote is the y-axis. So for the other part of the graph, we are sketching it here. This is the asymptote, and the y-axis is also the asymptote. So our graph will look like this. So now we will label this F. And then we also have G. We have G. Let us find the x and y intercept of G so that we can draw G. So first we will find the y-intercept. So that means x will be equal to a 0. So that's G of 0 equal to 0 plus 3. So G of 0 will be equal to a 3. So that means the y-intercept of G will be 0, 3. And then what about the x-intercept? So for the x-intercept, y will be equal to 0. So that means that will be 0 equal to x plus 3. So to make x the subject, that means we have to take the positive 3 from the right hand side to the left hand side. So we will subtract 3 and also subtract 3 here. This will be a 0, such that x will be equal to a negative 3. And then that means the x-intercept will be negative 3, 0. Okay, let's go to our graph. We have the x-intercept negative 3, 0. And then the y-intercept is at 0, 3. So we have the y-intercept at 0, 3. So it's here at the intersection of the asymptotes. So now let us sketch G. So G will be like this. You can use a ruler here because it's a straight line. Okay, and then you label this G. So for the coordinates, this is -3, 0. And then here we have -4, 0. And then we have the y-intercept, which is 0, 3. Okay, we have indicated our intercept and we have indicated their asymptotes. I think that's just it. That is how we sketch the graph of f and g. So that means we are done with question 4. Well, guys and girls, that marks the end of part 1 of this tutorial. Make sure you also check out part 2 of the tutorial where we will be doing trigonometry and geometry. Also remember that we also offer private tutorials here on Student Tools. To get that, you will need to sign up by clicking on this pop-up here at the top right hand corner of your screen, or simply use the link in the description. When you sign up for private tutorials, you also get some other cool benefits which are part of the package. For example, part 2 of this tutorial is already available to those of you that have already signed up for private tutorials. Alright, great turns. Let's meet again, same time, same place next week. Bye bye.